Okay, we're going to look at this one more way, and that is using geometry to solve reactions of a single force. So I'm going to try to do this, kind of showing you this program. It's like 15 bucks. It's definitely a fun one. I'm going to kind of just draft this. I draft the line across there. I'm going to call that my beam. I can now click on that, right click, and make it basically a nice thick line. And I can put on it perhaps one single force. Put that little force there from there to there. Oh. So I got a force, if I would, and on a beam. And that force, I can take that force and measure its length. And I'll put the length there. So that's AB. That's the force. We'll call it centimeters. We'll call it pounds, whatever. What I realized then is that the value of the moment arm, I can sketch in the moment arm by taking this point, holding a shift line, and going ahead and constructing a, try it again, by going to a point and a line. I should be able to construct a perpendicular line. I do that so I can put a point at the intersection, and then so I can put a circle that's defined by that, and lots of different things I can probably do. Like one thing I could do is go ahead and hide that, but I'll leave that for now. But what we realize is that definition of that circle I can put here, and I can measure the radius of the circle. So this circle here realistically is actually the moment arm of that force. And so if I move this force, shift it around in some way, shape, that moment arm will calculate. And in the end, I can then calculate the moment of the force about point C by clicking on this value here, and this value here, which is the length AB, and I can do a number. I can calculate a number, and the number is going to be basically, I can grab this one and this one. I was incorrect in that. In other words, the force and the moment arm, and then calculate a number. That number will be that times that. So this is the value of the torque, or the moment of that. Force times orthogonal distance. Force being symbolized by the A towards B, and the perpendicular distance being CD. That's giving me more or less the torque right here. Now if we think about that being reacted to by a force right here that's going up, try to hold that shift key here. I hold that force up. That force here has a moment arm, if you think about it, which is equal to this circle. Right to there. So if I more or less go ahead and say, well, that's one thing I can measure. I can measure that, and I can say measure length. Now that's that length, and we're going to change it in a little bit. And I can also measure this here. Measure, click on too many things, click on that and say measure the radius. And so in this point I can go ahead and click on this and this, and I can do a number, and I can calculate one times the other. And if I notice this times that is equal to that, well, that doesn't work for me, because in reaction this is spinning 9.14 and this is only spinning at 3.05. Now I'm not going to shift this back and forth, but I can more or less, if I move this up, I can move it up to a point. Trying to hold the shift key here, move it up to a point where essentially that shows me the reaction of that force on this. So just by that, you can start to see how calculations can be done graphically. And instead of this being something you pull, you can actually do some mathematic calculations. And I believe I have some videos posted on that. But for instance, what you can see in terms of this is if all of a sudden that force is going to be something more like this, you notice that values of 9.33 or 6.06, well, that would be less of a force of reaction. This would take my reaction force down to something like that. If I took it up to here, in other words, it became more orthogonal. Now you had a value here. Maybe there's the value there. You might have a value there of 8.01. This would require a larger force to resist it. Of course, then what you have to do, you need to do it on both axes. So I'll try to finally figure that out within the next 10 minutes. The last 10 minutes is we know that there is also a force. And let me go ahead and change that if we can. Change the color to that. I think you can change the color. Display, color, yellow. So I'll click that. Display, color, yellow. So that reaction force is yellow. And we know that there's a reaction force here as well, holding the shift key going up. And that reaction force is a little bit different now, because now I'm going to draft a line. I'm going to grab this same line of force there, and point F, which is my other reaction, I'm going to construct a perpendicular line. And so I need to get, once again, that is my moment arm. And so I'm going to go ahead, that one, of course, we need to first maybe go ahead and change our color again so we can not get lost. And I'm going to draft a line, not a line segment, but a line on top of this here. So that's not going to do it for me. I'm going to do an edit, undo. I want to actually draft a whole line between here and there, which means now, since I have this perpendicular to that, I can put a point here. And then I can go ahead and construct a circle from there through that point. This, of course, being the moment arm of this force AB about point E. So you've got now this circle as compares to this other huge circle, which is the same as this always was. It's the distance between the supports here. So you then have a reaction back here. And so you can basically take this distance from E to here, like that there, which I can't grab, but if I go ahead and put a line between here and there, or even better yet, edit, undo, we could have grabbed that. Sorry. You can click on that and measure that circle. Right? That's that circle there. And of course, that circle, right, is times this force, AB, gets you the torque. So once again, you can grab that, and then the length of AB, which was our force, and you can do number, calculate, values, that, times that. And that gets you the force of reaction to this force. In other words, this moment has, this force has a moment about this force of 11.29, but of this one, you see it's a little bit farther away, of 16.01, which means that this one here, right, would have to be a little bit more. Interesting that it follows that around. Nice. All right, so that's just basically something, you don't want to master this, but it's a great program, incredibly good resources out there for it. And it's at $15 for a set of family. It's not bad. And it does show you one more time how this is really just about comparing moment arms or moment circles if you think about that. So I'm going to place this one out and have this in class over the next 4 weeks so you can be exposed to the geometry and not just the algebra of the most basic concept of the lever and how it works within structures. Thanks for listening.